Hi, Kamba AY is my name. This is Series 2, Unit 2 of our video, and it is a continuation of Series 2, Unit 1 on Simple Regression Model. So in this series, we'll be looking at how the Simple Regression Model is estimated. Okay, now to estimate the parameters of a simple linear regression model, we make three assumptions about the error term. The first is that the error term is a random variable. So this means that the error term can take on any value, positive, negative, or zero. Then the second assumption is that the expected value of the error term is zero. That is, the mean or the mathematical expectation of the error term is zero. Since the mean of error term is zero, it's expected that error term has a constant variance. Then the third assumption we made here is that the model containing the error term is a simple linear model. That is, the model we want to estimate its parameter is a simple linear model, not a non-linear model. So the model is given in the form represented in equation 1 below, y is equals to alpha plus bx plus beta x plus mu. So how do we now go about estimating the parameters of this model? The first thing is, we're going to derive from equation 1 two simultaneous equations, and these simultaneous equations are called normal equations. After deriving the two equations, we derive, the equations are derived by using the method of ordinary least square, and the ordinary least square method requires that we minimize the sum of square residual. As we continue, we're going to understand what we mean by this. Then the second thing is, we're going to set the normal equation derived earlier in matrix form. Then the Cramer's rule is going to be used to solve or find solution to the systems of equations. The solution becomes the estimates for the parameter, or the formula required to estimate the parameters of the model. Okay, now to do so, I have equation 1, 2, and 3 here. Equation 1 says that y is equals to alpha plus bx plus mu. I am using alpha here in place of bo and b here in place of b1 used in our earlier demonstrations. This is allowed. In fact, you can choose ao and a1 in place of alpha and beta. You can choose bo and b1 in place of alpha and beta. You can choose b1 and b2 in place of alpha and beta. All the Greek words that you are familiar with can be used in your own analysis. Okay, now, equation 1 is different from equation 2. Equation 1 is an unestimated model. That is why it has the error term. Then the equation 2 is an estimated model. That is why you can see that the model is carrying cap. We have y cap equals to alpha cap plus beta cap x. So this is to tell you that alpha cap is the estimated value of alpha, the original alpha. Beta cap is the estimated value of beta, the original beta. And of course, y cap is the estimated value of y, the original y. So if we take the difference between equation 1 and equation 2, in fact, if you look at equation 1 and 2, you see that the difference between the two is just the error term. So error is simply the difference between equation 1, which is y, and equation 2, which is y cap. Now, we substitute equation 2 into 3 to obtain this equation. You see, we have mu now equals to y minus what you have here in this bracket, this alpha cap plus beta cap x, is simply this equation 2. It's very simple. It's a very simple logic. That is, this y cap has been substituted with alpha cap plus beta cap x, since that is the value of y cap. So that is what we have done here. So this one means y minus all this one represent y cap. What you have here all represents y cap. So this is like saying y minus y cap. We are now bringing in here the value of y cap, which we already have in equation 2. So that's what we have in equation 4a. So if we open this bracket, y multiplied by alpha, minus multiplied by alpha will give us minus alpha. And of course, minus multiplied by plus will give us this minus, and then we have beta x. So here we have opened the bracket, in equation 4a to obtain equation 4b. So the next thing is we are going to take the square of both sides of equation 4b. So we have the mu square is equals to y minus alpha cap minus beta cap x all square. This is very simple, just to take the square of both sides. Then we now take the sum of both sides of this equation 5. Sorry, not both sides of 4, it should be both sides of equation 5. So that means we're going to attach summation value, okay, to each side of the equation. So we have summation mu square equals to summation y minus. So equation 5 and equation 6 differs only by including the summation in both sides of the equation. Equation 5 and equation 4b differs only by introducing square into each of the sides of the equation. I'm sure this is very clear. So we have summation mu square equals to summation y minus alpha cap minus beta cap x all square. So now this equation 6 is the sum of square equation or sum of the square error, and our objective is to minimize the sum of square error. To do this, the first order condition is that we take the partial derivative of summation mu square, which is in the left hand side, and of course we equate each to 0. How do we do so? How do we do that? Okay, so this is the partial derivative of mu square with respect to alpha cap, and of course this is what we are going to have. We know the principle of derivation, so we're going to multiply the power by everything raised to that power minus 1, and then we multiply it again by the coefficient of alpha cap, since we are taking the derivative with respect to alpha cap. That is what we have done here. So the power, which is 2, multiplied by everything raised to the power minus 1, that is 2 minus 1, and 2 minus 1 will give us 1, then times the coefficient of that alpha, this alpha cap that we are differentiating with respect to it. This alpha cap here, if you come here, you see that its coefficient is minus, that is minus 1. That's why we multiply it by minus 1, and everything is equals to 0. So if we have this equals to 0, there are two things here. Minus 1 multiplied by 2 will give us minus 2. Okay, so we have other entities, other entries remaining the same. Okay, now when you have two products equals to 0, one of them must be equals to 0 for that. If you say x multiplied by y is equals to 0, either x must be 0 if y is not 0, or y must be 0 if x is not 0. So we already know that minus 2 multiplied by all the quantity is equals to 0, and since we know that minus 2 is not equals to 0, then the quantity summation y minus alpha cap minus beta cap x must be equals to 0. So if we open this bracket, we are going to have summation times y summation y minus summation times alpha summation alpha cap minus summation times beta cap x will give us beta cap summation x. When you are taking the summation of two quantities, one of them constant and the other variable, the constant, the principle of sigma notation is that the parameter will come to the back of the summation while the variable will be at the front. So that is why when we say summation multiplied by beta cap x, we now have beta cap summation x, not x summation beta cap. It is the constant term that will come to the back of the summation, and of course the variable at the front. So this is equals to 0. Now we now have summation y. If we take now summation alpha cap is the same thing as n alpha. I think there is a way we demonstrate this. If you take the summation of a constant value, suppose you have 2 in 5 places. Now, the summation of 2 will be 2 plus 2 plus 2 plus 2 plus 2 in 5 places, and that will be 10. So it's as good as saying that since the total number of 2 is 5, 5 multiplied by 2 will be 10. So it will give you the same thing. So the total number of a constant, the summation of a constant is the total number of that constant, that is n, multiplied by just one value of the constant. It will give you this. So that is what we have demonstrated here. Summation alpha cap will be equals to n alpha cap, then minus beta cap summation x. So here we now make summation y the subject of formula to arrive at what we have in equation 7. So equation 7 becomes the first normal equation. Then to get the second normal equation, we now differentiate summation mu square again, but this time around with respect to beta. We differentiate with respect to alpha to get the first normal equation. To get the second normal equation, we differentiate now with respect to beta cap. So from the equation now, You see, the derivative of summation mu square with respect to beta cap using the same procedure. Here we are going to multiply by the coefficient of, okay, it will be now 2 multiplied by everything raised to power 2 minus 1. 2 minus 1 is equals to 1. That is how we arrive at this one. Now, times the coefficient of beta cap. What is the coefficient of beta cap here? Is this minus and this x. So that's why we have times minus x here. So if we multiply 2 by this minus, we're going to have minus 2, okay, times everything. So here, because that is the x attached to, the minus attached to x here, we multiply it by 2 to have minus 2, so that we have only x here and everything equals to 0. So the same principle, since minus 2 is not equals to 0, then the quantity summation y minus alpha cap minus beta cap x times x must be equals to 0. So if we open this bracket, we're going to have x times y, we're going to have xy, x times alpha cap, we're going to have alpha cap x, x multiplied by beta cap x, we're going to have beta cap x square. So now we open the bracket. Now summation times sy, summation sy. Summation times this will give us alpha summation x, and summation times beta cap x square will give us beta cap summation x square, all is equals to 0. So we now make summation xy the subject of formula to arrive at what we have in equation 8. So equation 8 becomes the second normal equation. So remember, the next thing to do is that we are going to set equations 8, equation 7 and equation 8 in matrix form, as we mentioned earlier. So here I said equation 7 and 8 are called the normal equation. So let's set it in matrix form. Then we now use, okay, look at it. Now the normal equations are arranged in matrix system as follow. Okay, look at equation 7, look at equation 8. So you see, the first equation here is the first entry in this matrix. We have three things here. We have matrix of the coefficients here, and we have the matrix of the parameter alpha and beta, and then we have the matrix of this number here. Okay, this summation y and summation xy, we call it matrix of the results. Okay, so what do we do here now? To get alpha cap, we replace this first column n and x by this result matrix here. And then we divide whatever we have by the entire matrix. Okay, this is what I'm saying here. You can see that this matrix at the top, the difference between matrix at the top and matrix at the bottom here is just this column here. This column here, okay, the column summation y and summation xy that we replace with this n and summation x. Then we divide it by the original matrix. And how do we do? So what do we do now? We now cross multiply each of the matrix. We're going to have summation x times summation x square, summation y rather, times summation x square minus summation x. Okay, I mean this summation y times this summation x square, then minus this summation x times this summation xy. That is, we cross multiply this, and of course this and this. So that's what we have. Summation y multiplied by summation x square will give us summation y summation x square minus then summation x multiplied by summation xy will give us summation x summation xy. Then divided by, now we do the same thing here. N multiplied by summation x square will give us n summation x square minus, now summation x multiplied by summation s will give us summation x all square. So this quantity you are seeing here is the estimate for alpha cap. That is, this is the formula we can use to estimate the value of alpha cap. So the same thing we have for beta cap. To get beta cap, we replace this second column of the original matrix by this summation y and summation s square, and then we perform the same operation we have done here earlier for alpha to arrive at n summation sy minus summation x summation y over n summation s square minus summation x all square. Thank you very much. Don't forget to like, share, and subscribe.